Hello, this is Alex Berklow, and I'm here at IBC in Amsterdam at the AWS booth in the Data Science and Analytics pod. And I'm going to be talking about the demos that we're showing here today at the show. I'm going to give you an example of semantic search, right? So this is actually taking advantage of semantic search similar to the previous demo that I showed, but it's using it in a different way. This is actually directed towards, we're imagining that we are journalists writing an article or editors who are creating an article for a magazine. And so I'm typing in my text and I want to find images within my archive that would go well with my article. So I want to reuse the content that I already have within my image archive. And the way that we're doing this is we're using those vector embeddings again. So we're able to use Amazon Bedrock to generate vector embeddings for the sentence. And then we're also using Amazon recognition on the images to get object labels and celebrities. And we're also mapping that into the same vector space. And then we're using semantic search to find relevant images within our archive that will match the text in the article. So you can actually see that we never said volleyball in this text, but it came up with some very relevant, volleyball images with sports. So we're also looking for people, so we're just doing a celebrity search in addition to this, so we're incorporating that here. So let me just copy that one in and replace the text. And we'll search. So in this case, our own celebrity, Werner Vogels, is the person that is the known person in this context. He's traveling around the globe in his Toyota. So we come up with images of Werner Vogels. We don't see necessarily a Toyota, but Toyota is car, and the language model is able to, if it doesn't find a Toyota, it's finding semantically similar items to the car that's mentioned in the ad, so less specific. So another thing that our customers have asked us for is to help enhance their productivity in creating promotional information or thumbnails and packaging and for distribution of their videos. So some of the images and the content writing that goes into the packages as they distribute and localize their videos, articles to different regions or to different consumers. And so one of the things that they say is that for each piece of media, they're generating hundreds, and even for higher level productions, even thousands of artifacts per video per region. And it's a bottleneck for them about how many regions they can actually reach with the resources that they have. And so they're looking for ways to streamline that and make it so that the people who are doing it can go faster in that workflow. And so this is showing generative AI for creative content. So you're taking your existing images and you can replace elements of the image or change the background of the image using machine learning. And I'll just show an example. So in this example, this is called infill. And so what I'll do is I'm going to select the dog in this image, and every object in this image is segmented by the machine learning. It's a segmentation model. So the segmentation model is, I can then select the different objects because we've already pre-segmented this image. I've selected the dog, and now I can just remove the dog from the image. So this is called infill. So it's going to take the background and try to repeat it in the resulting image. And then we also have outpainting, which allows you to both replace objects and remove or replace the background of an object. So I have some examples I can show here. The first one is a background replacement operation. So once again, I'm going to select the dog, but this time I'm going to change the location where the dog is. So you can see that the prompt, that's just for convenience, we're automatically filling in the prompt to go faster. So it's a dog at a space museum. So I'm going to go ahead and generate the result for that. Okay, and so we've changed the location of the dog into the Space Museum, and it blends rather nicely into the background image. And we can make some adjustments. We can give guidance to the machine learning in order to adjust how many inference steps it takes, how much computation it does. So the last demo that I would like to show is Media to Cloud. So Media to Cloud is our media archive solution. So it helps you to ingest your video data into the cloud, as well as audio and text, photos, and then be able to enhance it with metadata that helps you to search and find your content. So we already had the AI service generated content like computer vision and transcripts that we could use to search for content. In this iteration of Media to Cloud, we've actually added some generative AI capabilities. So we've actually added the ability to summarize text, determine the genre of text, find the sentiment within the text of a video, and also to categorize the video by its MPA rating. We have also added some new metadata around segmentation. Amazon Recognition supports shot detection. So a new functionality has been added to Media to Cloud to actually detect scenes. If the content is like action, like say a fast car is driving through the frame, that's one scene, right? That's what we consider one scene, but shot detection will consider that multiple shots because of the change. And so what this algorithm is doing is actually looking at using a comparison algorithm between the frames to filter out those action shots, into a scene so that we can actually group them into what we really want to find segments in our video. So this is very exciting. It enables a lot of clipping workflows that before wouldn't have worked very well. So this is very exciting as a piece of metadata that can be used in downstream workflows. An example of a downstream workflow is ad breaks. So we're actually using that scene detection data, and we're generating good places to put ads in a piece of content. And if we look at the metadata for this, you can see that the shot information is there, the scene information is there, and we're also providing contextual metadata about each slot where an advertisement could go to help inform an ad server about what would be a good ad to place in that slot. So this is something customers have been asking for. We've had several iterations of solutions around this, but the scene detection functionality that was added is going to really make a higher quality detection for this. All right, so thanks for joining us at the Data Science and Analytics booth at IBC 2023. Please reach out.